Hello everyone, welcome back to Physics Powerplay, and this is lecture 3. And in this video, I'm going to talk about laws of motion, second part. The previous video, I talked about the basic one, around 20 questions we solved it, and I tried to solve about 15 questions in this video. Okay, let's go on. These are all PYQ selected questions we are talking about. Okay, read on. A coin placed on a rotating table just slips when it's placed at a distance of 1 centimeter. So whenever you see just slips, immediately the triggerant should be limiting friction, limiting static friction at a distance of 1 centimeter from the center. If the angular velocity of the table is half, it will just slip again when placed at a distance of, okay, just slipping situation they are talking about, meaning limiting friction. First of all, what is the motion of the coin here? You have a rotating table. When you place a coin there, it will go in a circular path and it is going to go in a horizontal circle. So whenever you require circular motion, there must be a centripetal force acting. Without centripetal force, circular motion is not possible. And because it is in horizontal plane, so centripetal force has to be horizontal only. And if you draw the free body diagram to it, there is mg vertically downward. That does not produce centripetal acceleration because horizontal component of mg is 0. Balancing mg, you have normal reaction. Normal reaction is vertical. Vertical force cannot produce horizontal acceleration. So mg and normal reaction, they balance out. But what is the force which is producing centripetal acceleration here? Don't say centripetal force. Centripetal force is a name of that force. And here centripetal force is friction. Only frictional force is acting horizontally, and that too static friction. And when it is about to slip, centripetal force is going to be limiting static friction. And now you may ask me, centripetal force, friction has to be opposite to velocity. That is a misconception. Friction need not be opposite to velocity. There are two kinds of friction. Kinetic friction will be opposite to relative velocity, not velocity. And similarly, static friction, when you have static friction, there is no relative velocity only. Then how can you have a opposite relative velocity? So direction of static friction is self-adjusting. It can be in any direction, just that it has to be in horizontal plane parallel to the surface of contact. It may be in the direction of velocity. It may be opposite to velocity. It may be perpendicular to velocity. It may make any angle with the velocity static friction. And here it is perpendicular to velocity because it is supposed to produce that centripetal acceleration. So limiting static friction is mv square by r or mr omega square. And limiting static friction is mu into n, and n is mg in this case. So mu you are not changing, mass is not changed, g is not changed. Anyway, mass even if you change also it doesn't matter. You see that r omega square is constant here. R omega square is constant. They are saying omega 1 is, let's say, omega. Omega 2 they are making omega by 2. They are reducing omega to half. R1 they had given R1 equal to 1 centimeter. What should be R2 where it is about to slip? That's what you have. R omega square equal to constant. That means R2 by R1 is going to be omega 1 by omega 2 the whole square. Alright. Omega 1 by omega 2 is 2. 2 square is going to be 4. Otherwise R2 equal to 4 times of R1. R1 is 1 centimeter, meaning you will get 4 centimeter. That's the answer, you have it. So what is centripetal force here? Static friction. And what is the direction of static friction here? Perpendicular to velocity. Need not be opposite to velocity, as you might, some of the students may have that misconception. Okay then, good. Next, a uniform chain of a 6 meter length is placed on a table such that the part of it is hanging over the edge of the table. The system is at rest. So obviously I'm going to deal with equilibrium situation here. The coefficient of static friction is given 0.5. Then how much is the maximum length of overhanging? Again, whenever you see maximum length or minimum length, maximum velocity, minimum velocity, that probably is related to limiting friction again. All right, limiting static friction here. So first of all, let us draw the diagram. You have part of the chain on the table and part of it is hanging. Okay. And now let us consider a situation of limiting friction when it is about to slip off. Let's assume that this mass is m1 and this mass is m2. Length is L1 and this is L2. And you know that mass proportional to length because they said uniform, no? Mass proportional to length. m1 by m2 equal to L1 by L2. And of course, we know L1 plus L2 equal to 6 meters. Total length of the chain is 6 meters. That you have it. Now we'll write equilibrium situation for each. So if I look at the hanging part and draw the free body diagram to that. So you have let's say tension T here, and balancing M1 into G. So you get T equal to M1G. That is one equation I'm getting. All right. Now you take this part of the chain. Actually, I'll cut it here. This part is cut here. This part is cut here. There is a tiny part of it which is neglected. Okay. We assume that tension here is almost equal to tension here. Magnitude wise, directions will be different. So if I take this part and draw the free body diagram, you have tension, same amount of tension approximately. And you have mg and normal reaction. All right. But horizontally, you have this limiting static friction. So same tension has to be equal to limiting static friction. Okay. But limiting static friction is what? Mu s into n. Mu s into n. And what is n here? The weight of the part which is on the board. So this is going to be mu s into m2 into g. Now combining 1 and 2, both are tension only. Left hand side equal, meaning right hand side equal. So what do I get? M1 into G equals to mu times of M2 into G. G gets cancelled out. M1 equal to mu M2. And now mass proportional to length, you will get L1 equal to mu L2. And I want that the student remember this formula. I ask the student to remember this. L1 is hanging part. That is equal to mu times the part of the length which is on the table when it is about to slip. L1 equal to mu L2. So that formula you can remember. Now we have two equations to solve two unknowns. I want L1. So L2 can be written as L1 by mu. L1 plus L1 by mu equals to 6 here by substituting here. They gave mu equal to 0.5. 1 by 0.5 is 2. So this will become 1 plus 2. 3 times of L1 equal to 6 or L1 equal to 2 meters. So if you remember this formula, you can straight away write it. L1 equal to mu times of L2. Please remember it and you'll be able to solve it very quickly. Right. Next problem. A curved, in a level road, a curved level road has a radius 75 meters. The maximum speed, again you see maximum speed, minimum speed, whenever they talk about, probably it's related to limiting friction. That should trigger. It's like a switch on, light on. Maximum speed, minimum speed, probably it is related to limiting friction. A car turning in this curved road will be 30 meters per second. So V1 max 30 meters per second. And what is the radius they have? 75 meters. See, as you are reading, how you convert that into data is also important here without skidding. That means static friction. What is the direction of static friction? We have seen the coin, right? Static friction direction is not opposite to velocity. It's actually perpendicular to velocity because that produces centripetal acceleration here. Okay. Now, if the radius of the curve is changed to 48 meters, then what is V2 max? He's asking. So that's a question you have. You have a circular path and it's a top view I'm looking at. Centripetal force is basically static friction. Limiting we are looking at. Then it is going to go with maximum speed. All right. So centripetal acceleration will be equal to V max square by R. And that is going to be equal to limiting friction by mass, which is mu G. Mu they are not changing. That means V max square is proportional to R. This is the relation I have it. Right? V max square is proportional to R because mu G is constant there. Once I have it, V1 by V2 whole square equal to R1 by R2. That idea we can write it. So I want V2. So I'll write it here. V2 by V1, the whole square, will be equal to R2 by R1. Fine. You can apply the root either side. What do I get? V2 by V1 equal to square root of R2 by R1. R2 is 48 by 75. Either 3 times it goes 16 by 25. The root of it will give you 4 by 5. So V2 by V1. V1 is how much? 30. 30 by 5 is 6. 6 4s are 24. So V2 equal to 24 is what you get. 24 meters per second is the velocity you get it. So my request for you would be, please try to solve simplification. You try to do it. I will try to spend more time on giving the idea. This manipulation, simplification unnecessarily increases the time. So I would like that I would do ideas, simplification, I mean that giving the formulation, equations, result, but simplification, I want that you try to spend time on that. Okay, then that will be better utilization of the time. The ball is released from rest. That means initial velocity is 0 from point P. So here, initial velocity is 0. Of a smooth hemispherical vessel, as shown in the figure. So it's spherical vessel, hemispherical vessel. You have smooth, they said, meaning no friction. It's not a friction related problem. The ratio of the centripetal force and normal reaction. Ratio of centripetal force to normal reaction. Centripetal force to normal reaction. And that is written as A. While angular position of Q equal to alpha as a function of alpha. A as a function of alpha they are talking about. Which of the following graphs represent the correct relation? See, they had given graphs, big graphs, but I didn't take it. We can actually solve it and plot the graph on our own. Right. First of all, if I release the particle here, why would it come down? Why will it go to Q? See, they didn't say it is a vertical plane. But the way they had given the wording, you have to assume it to be vertical plane. Otherwise, if you release it here, it will remain there if it's a horizontal plane. Because of gravity only, it is supposed to move. So it's actually vertical circular motion. Though they didn't mention it very clearly, specifically, but otherwise you will not be able to solve it. So it's a vertical circular motion. The moment you say vertical circular motion, you may have to use work-energy theorem or conservation of mechanical energy also, along with Newton's law. So that is one thing we have to use. Vertical circular motion, meaning immediately idea. Either work-energy theorem, conservation of energy must, especially to find speed and omega. Okay, so let me use conservation of mechanical energy. I use this phrase like this, COME, conservation of mechanical energy. So as it falls from P to Q, there is a descendancy of height, loss in gravitational potential energy. That will be mgh. And that is equal to gain in kinetic energy, half mv square. All right. Okay, that I'm going to use. Now they're asking you to find A by this. First, let us write mv square by r. You take h this side. First of all, let's calculate h. What is the value of h here? Where do I do undo? What is h here? You look at this right angle triangle. See, generally in physics, geometry meaning mostly right angle triangle, sine theta, cos theta only you will have it. Don't think too much about geometry of physics here. Most of the time, right angle triangle here. So you have this radius as hypotenuse, opposite side I require. So h would become r sine alpha, opposite side. If I substitute there, mg into r sine alpha equals to half mv square. From there, I can calculate mv square by r. mv square by r equal to 2mg sine alpha. So this is one equation. What is mv square by r? It is centripetal force, magnitude of centripetal force. Okay, centripetal force, I got it. But normal reaction I require, right? So to find normal reaction, I'll have to use free body diagram, and probably I have to use dynamics of circular motion. So over here, normal reaction will be normal to the surface. All right. The ball will press the ground, that surface in this direction, action to reaction, the surface will push it towards the center there. And mg will be vertical. If radius makes an angle alpha with the horizontal, tangent makes an angle alpha with the vertical. So mg is like this, its tangential component would be mg cos alpha. And then mg sin alpha will be in this direction. So same centripetal force, whatever centripetal force we were talking about, that is mv square by r, which we got it already, which is 2mg sin alpha, should also be equal to net force directed towards the center, which is n minus mg sin alpha. So from there I can calculate n also. mv square by r we got it. You can substitute it as 2mg sin alpha. So you take this side and you will get n equal to 3mg sin alpha. I'm trying to bring everything in terms of alpha, because they are asking a as a function of alpha. No? So n we got in terms of alpha, and mv square by r also we got in terms of alpha. You look at the equation 1 and equation 2. Now let's substitute here. A of alpha, first centripetal force, how much is that? 2mg sin alpha. And normal reaction is 3mg sin alpha. So you see everything is getting cancelled out, all the variables are gone, it is going to be constant 2 by 3. And so you will have a constant function graph. A versus alpha graph, if you plot, it will be constant. up to alpha equal to whatever. Let's say it starts 0, that will be 90 degrees or 180 degrees to the other side. This is how you have the graph there. So I hope you got it. I think up to here, this is okay. Let's go on. I think up to there, from here to there, assuming that there is no friction, it will oscillate with a 90 degrees amplitude, pendulum type, not simple harmonic, but periodic motion. Okay, then let's move on. Yeah, this is string constraint basically. I'll use power method. Very powerful method, power method. So some faculty, they call it as virtual work method, but I would like to call it as power method. Okay. So the concept here is very simple. String and pulleys, massless pulleys, they cannot store any energy, neither in the form of kinetic energy nor in the form of potential energy, gravity or strain, because they are ideal, no deformation, no mass. So net work done on the system or net work done by the system will be 0 if it is not able to store energy. Okay, that's idea. Work done 0 meaning power also would be 0. So you will get sigma TI Ti bar dot Vi bar equals to 0. This is what I'm going to use. Okay. If you want, you can differentiate once. Assuming tensions are equal, if the tensions are constants, not necessarily equal, if tensions are constants, it will become Ti bar dot Ei bar will be 0 by differentiating it. I'm doing differentiation here. Okay. So this is a formula I'm going to use. The moment you see the diagram, immediately I didn't read the question also. First, I have to use this power method. That's the idea I'm getting it. Now, let's read it. In the arrangement shown in the figure, A1, A2, A3, A4 are the accelerations of the masses. Then which of the following relation is true? They gave the relations, I'll just write it there. So let's assume that it is going with A1 acceleration, going with A2 acceleration, A3 acceleration, A4 acceleration. They didn't give the direction there. We take one direction. If you get negative value, you can reverse it. Now tensions I have to calculate. Let's say tension here is T, then here also tension T by pulley equilibrium, this should be 2T, then obviously this is 2T, one string, one tension when there is no friction. So 2T meaning 4T here, and again you will have 4T here. Now if I write it, what do I get? 4T into A1 plus 2T into A2 plus T into A3 plus T into A4 equals to 0. Now, if T is not 0, only power method works when T is not 0. If T is not 0, tension can be cancelled out. Alright. Then you have 4A1 plus 2A2 plus A3 plus A4 equals to 0. So, this is a very powerful method, right? Just like that, you can get the answers using this virtual work method or power method. Very powerful method. But this works only when tension is not 0. Please remember that. There are some questions where tension was 0, and if you apply power method, you will get a wrong result there. So be careful about it. Okay, then. Next. A system of 10 balls, each of mass 2 kg, are connected by a massless and unstretchable string. Okay. The system is allowed to slip over the edge of a smooth table, so no friction here, as shown in the figure. Tension on the string between 7th and 8th ball is this much, where when 6th ball just leaves the table. Okay, first we need to draw the diagram, otherwise the problem will be very simple. So let's consider this is a table we have. So 6th ball is just dropping off, just slip off the table, just came out of the table. Then 5th will be here, 4th is here, 3rd, 2nd, 1st, all connected. Then on the table, how many would be there? 7th ball would be there, 8th ball would be there, 9th, and then 10th. Separation is constant only. Okay, everywhere separation is not changing because it's unstretched there. So this is 8th ball, this is 9th ball and 10th ball. This is what I have here. 4 balls on the table and 6 balls are hanging right now. And obviously they're accelerating. Let's say they're having A acceleration. They're all going to have common acceleration A like this. Okay, I think we have done it yesterday also in the previous session where we need to find the acceleration. Acceleration will be simply net unbalanced force by total mass. Here unbalanced force is only the weight of this. Unbalanced force will be 6 mg divided by total mass is 10 m. This works pretty well when magnitude of acceleration is same for all the bodies, connected bodies. So you will get 0.6 g, meaning I'll take g as 10, you will get 10 meter per second, 6 meter per second square. That's acceleration, you have it. Okay, I got the acceleration. They're not asking acceleration. They're asking you to find the tension between 7th ball and 8th ball. This is 7th ball, this is 8th ball. And this is where they're asking you to find the tension. This tension they're asking. So what I can do is I'll take a free body diagram. See, whenever you want to find unknown force, Newton's law you have to apply. Usually 99.99% of the time, whenever they ask you to find any force, immediately remember you have to use Newton's law. But for you to use Newton's law, you have to take an appropriate free body diagram. So I will choose this free body diagram where the only horizontal external force is that tension. This tension is pulling these three. So T equals to these three masses, 3m into the same acceleration they are having. 3 into what was the mass they had given each ball 2 kg, acceleration was 6. So 6 are 36. And that is the answer to it. So very simple problem. Only thing is diagram you should be able to draw based on reading comprehension. It's more of reading comprehension based question. Okay, then next. A system of two blocks of masses 2 kg and m equal to 8 kg placed on a smooth table as shown in the figure. The coefficient of static friction between them is given 0.5. Many times they are giving 0.5 only. Mu value. The maximum horizontal force F that can be applied to the block. See, whenever you see maximum, minimum meaning limiting friction idea. So that can be applied between these two. Of course, there is no friction here, but between these two, there is a friction. Right. What is the maximum force? See, there are two conditions here. One condition is we have to find F max. F max meaning I have to find, let's say this is A1, this is A2. I want to have A1 max. Maximum acceleration I want. That is one condition I need to satisfy. And the second condition is that they should move together, they are saying. So when they are moving together, they need to have A1 equal to A2. I have to make sure that A1 equal to A2, that is one condition. Then only they'll go together. Static friction, you will have it. Limiting static friction, probably. But A1 maximum. What is the maximum acceleration that you can have it? So now you focus on small m. Why should small m move? I'm applying force on capital M. Capital M will move. Why will small m move? So if it is moving, it is only because of the force between them, that is friction there. So actually the friction is actually supporting the acceleration of mass. So don't think that friction opposes the motion all the times. Here the friction is supporting the motion of small m there. So F equal to m into A1. Alright. When I go for maximum acceleration, that would correspond to F max. And that is equal to m into A1 max. And F max is how much? Mu mg. Alright. And you see that A1 maximum is going to be mu g. So one small m cannot go faster than mu g. Whatever may be the acceleration that you have here based on applied force, this guy cannot accelerate more than mu g because the acceleration of this is only due to friction there. So when both of them are going together with the maximum possible acceleration, then A1 equal to mu g, A2 is also going to be mu g, and both are going together with common acceleration. Net force is equal to total mass into that common acceleration you have it. And that is going to be the answer here. That is F max. So m plus m, 10, mu is 0.5 into g is 10, you will get 50 Newton. A very simple, straightforward question. In fact, it is something that you remember it as a formula. Those who prepare for NEET examination, they remember it. F max equal to mu into small m plus capital M into g. Okay, logic is this. Mu g is the maximum common acceleration, they can have it. Okay, next. A block of mass 2 kg is moving on a horizontal surface with a speed of 4 meters per second and enters a rough surface ranging from x equal to 0.5 to 1.5. The retarding force in this range is given. Okay, F is given, F equal to minus kx, k is given 12 Newton per meter should be. The speed of the block just as it crosses the rough surface. So you have, let's say this is x equal to 0, this is x equal to 0.5, and then x equal to 1.5. X equal to 1.5, you have it. So this region is rough. Only in this region friction is present. It is entering with a speed some u, and it is going to leave with what speed? That is what he is asking. U is given 4 meters per second. So what is the velocity with which it comes out? Basically there will be retardation. But here main problem is the force is a variable force. So if force was constant force, then you will get acceleration constant. When acceleration is constant, you can use kinematic equations v square minus u square equal to 2as. You cannot use kinematic equation here. Please remember that. You have to go with calculus. This is a calculus based question. So you write F equal to minus kx and that is equal to mass into acceleration. You will get acceleration equal to minus kx by m. Now I need to find velocity. So acceleration can either be written as dv by dt, or otherwise I can write it as v dv by dx. Which one do you think is better here? Say left hand side you have x terms, right hand side if you bring in t, you will be having three variables in one equation. You will not be able to solve it. So it's better to use this part of it. Okay, then rearrange the terms. For how much will you get? Minus k by m into x dx is going to be v dv, and integrate. When x is equal to 0.5, v equal to u. When x is equal to 1.5, what is v? All right, everything is available there. You can integrate it and get it. Okay, I'm not doing the calculation part of it. I request you to do the calculation part. I would like to spend more time on giving logic ideas there. Okay, this is one method. There could other be also one more method if you can solve it a bit, if you observe it carefully, if you have a keen observation. You see this force how it is, F equal to minus kx. F equal to kx, the moment you see a spring force should trigger. It looks like a spring force only. So because it looks like spring force, I can associate a potential energy to it. Potential energy will be half kx square. Even though it is retarding force, it is conservative force. It depends only on position, not the path. Okay, very good. Now, once I have potential energy, I can use work done equal to minus delta U. I hope you know that whenever a conservative force works, it loses energy. That's why that minus there. So that will be equal to minus of half k into x final square minus x initial square. And using work energy theorem, this must be equal to half m into v square minus u square. Okay, that's all. Problem is over. So k is given 12, x final is 1.5, x initial is 0.5, mass is given, v we have to calculate, and u is also given there. This is one more method. One method is calculus. See, whenever you go into kinematics, right? Kinematics, if it is constant acceleration, simple. Otherwise, you have to use calculus. If you don't want to go with calculus, there is alternate method, which is going to be work energy theorem. All right, or conservation of mechanical energy whenever there is a possibility. So this is what I have. I wanted to complete this. Let's move on with the next problem. Wire of length L is hanging from a fixed support. The length changes to L1 and L2 when mass is 1 kg and 2 kg suspended respectively. So this length L, so if you read it properly, it looks like it is a natural length. Natural length, meaning when you don't hang anything, that is the length it is going to have. When you hang 1 kg, it is becoming L1. When you hang 2 kg, it is becoming L2. So let us draw the diagram here. All right. So first situation, you are hanging, let's say M1. I'll do it symbolically. And the length is L1. The second situation, you are hanging M2, 2 kg, and the length has become L2. But natural length is L. We can find elongation in this case. That will be L1 minus L. Okay. And elongation in this case will be L2 minus L. Existing length minus natural length. Because of elongation, there will be spring force here. K into E1. And here the spring force is K into E2. And why do you need that? Because I think I have moved to the next page. Let me go on back again. So the previous one. Okay, right. So you have M1G and this is M2G. And they are in equilibrium. That's assumption here, not accelerating. So K into E1, that is K into L1 minus L equals to M1 into G. Same way for the second one, K into L2 minus L equals to M2G. These are the equations, you have it. All right. Now take the ratio, K will cancel out. We don't need K. What do I get? L2 minus L divided by L1 minus L equals to M2 by M1. M2, M1, 2 and 1 you have, that is 2. Just take the cross multiplication, you will get L in terms of that. Say L2 minus L equal to 2L1 minus 2L. So I'll take L this side, and or rather I'll go in the other direction. So where do I do? Undo. Okay. So let us take 2L this side and L2 this side. 2L minus L equals to 2L1 minus L2, or L equal to 2L1 minus L2 is what you are getting. That's a very straightforward question. I don't know, some more students are facing little difficulty, though the problem is very simple, but I hope you got the clarity in it. Let's move on to the next problem there. A block of metal weighing 2 kg is resting on a frictionless plane. It is struck by a jet of water releasing at a rate of 1 kg per second. And the speed is also given. Mass flow rate is given. Speed is also given. Speed is 10 meter per second. Then they are asking initial acceleration. They are asking only initial acceleration. Initial acceleration meaning when velocity of the block is still 0. It hasn't started moving. Acceleration, velocity is 0, but acceleration is how much? That's what they are asking about. So this is one different kind of a problem where you require a slightly different method. So the idea is this is somewhat kind of a variable mass system. We need to find the thrust force here. The concept that we are going to use here is F net is equal to dp by dt. This is the idea I'm going to use here. All right. So what we do is we take a small tiny piece of mass dm. All right. The dm, if you consider, initially it is having a velocity v. Initially it is having a velocity v, but finally it comes to rest because it hits the wall. We are not considering splashing of water. Generally they are supposed to mention it. There is no splashing or perfectly inelastic, they would say generally. Before colliding with the wall, it has got v velocity, but after colliding, it has come to rest and then slipping over. So then if I calculate initial momentum if I calculate, initial momentum is dm into v, final momentum is 0. Now I want to find the change in momentum. They say dp, that is change in momentum, p final minus p initial, finally 0, initially minus dm into v. That is a change in momentum. Now if you divide by dt either side, you will get the force. That is going to be the force there. I'm giving you a formula. So what is the thrust force on the liquid? Thrust force on the liquid is going to be minus of dm by dt into v. That is the thrust force on the liquid. I don't want thrust force on the liquid. I want thrust force on the block. So action to reaction on the block, if you consider, it will be positive plus dm by dt into v. All right. Maybe you can remember it as a formula, but the derivation is very essential. This is something we are using a slightly different kind of method. It's not like F equal to ma you can use because mass is continuous here. You don't have discrete mass here. So this will work whenever you have flow, a continuous mass you have it. This is one method, you need to remember it. Okay, let's go on to the next problem. A block of mass capital M placed inside a box descends vertically with an acceleration A. Okay. The block exerts a force equal to 1/4 of its weight on the floor. Then value of A is. So you have the block and there is a platform which is coming down with acceleration A. The block is also coming down with acceleration A. They said that normal reaction is actually mg by 4, 1/4 of its weight. Of course, weight is there. Because of these two forces, it is having this acceleration and they're asking you to find the acceleration. Very straightforward. Net force in the direction of acceleration, mg minus n equals to m into a. N is mg by 4. mg minus mg by 4 is 3 mg by 4. 3 mg by 4 equals to m into a. mm gets cancelled, you will get 3g by 4. A equal to 3g by 4. That's the answer we have. Next problem. Three masses m equal to 100 kg and 10 kg and 20 kg are arranged as shown in the figure. All the surfaces are frictionless and the strings are inextensible, weightless. The pulleys are also weightless. Everything is frictionless and ideal. A force F is applied on the system on the mass. Then they said so that the mass M2 moves upwards with an acceleration 2 meter per second square. Okay. The value of F is. Actually, I think the diagram is not correct. So it is supposed to touch here. Okay. It is supposed to touch here. So when you push this, right, M2 will have horizontal acceleration also. Horizontally, it will have some A1 acceleration. In addition to that, because of the tension in the string, it will have vertical acceleration also. And from wedge constraint, whatever acceleration this guy is having, this guy also will have same acceleration. Along the normal, both of them same acceleration. A1, A1. All right, that's the situation you have. And probably this guy is having acceleration, or probably we'll take this as A0 and let us call this as A1. All right, that's the situation you have it. So first thing what I'll do is, I'll do it with respect to wedge first. If I do it with respect to wedge, string constraint will be taken care of. With respect to wedge, if you observe, then wedge is at rest. And wedge is at rest meaning pulley is at rest. Pulley is not moving, stationary pulley. All right. then this guy will not have any horizontal acceleration. Relative horizontal acceleration 0. Only vertical acceleration this guy will have 2 meter per second square. Then obviously this guy also should have 2 meter per second square acceleration because of the string constraint. The rate at which one end approaches the pulley is the rate at which other end is going away from the pulley. So that's the acceleration, you have it. Alright, now if I apply Newton's law here, we can write here tension is there and pseudo force will be there, m1 into a0. Why pseudo force? Because the block is having acceleration. With respect to non-inertial frame, you have to apply pseudo force. So you have m into a0 and t there. So m1 into a0 minus t equals to m1 into 2. Right, m1 they had given how much? 10. 10 into t is 20. And you get one relation here. T equal to how much? 2 into a0 minus 2. That is one equation. I got it. Now same tension I can calculate from this block also. Vertically, if you look at it, there is T here and there is M2G. There will be pseudo force on this also, but that will be horizontal, balancing normal reaction. Just focus on vertical forces here. So what do I have? T minus M2G equals to M2 into 2. So you will get T equal to M2 into G plus 2. So this way I can calculate M2, how much they had given? 20, G is 10, 10 plus 2, 12, 12 into 20, 240 Newton. So tension I got 240 Newton, that is the second equation I have it. The moment I have tension here, I can calculate A0. Alright, so we are using wedge constraint. How are we using wedge constraint? Along the normal, both the bodies are having same acceleration. We are also using string constraint. How are we using string constraint? With respect to pulley, whatever is the rate at which one end approaches, that's the rate with which other end is going away. So that's the idea we have 2 meter per second squared. Okay, so T I got it. We can also calculate normal reaction here because if you look at it in this line, there is a pseudo force in this direction, M1 into M2 into G, and then normal reaction in this direction. See, I'm writing everything here only because in the examination you won't get so much of space. In the limited space only we have to manage the time there, right? Some little bit of rough paper they'll give you, need to solve it. Better to use that limited space, whatever you have. Having pages and pages of rough page may not be that good. So I'm trying to use it here only like I'm solving in the examination. So what do I get? N equal to M2 into A0. A0 we got it, no? A0 we can calculate from here. How much are you getting? 240 by 2 is 120. 122. 122. 240. I think this is how much is tension here? T is M1. M1 is how much? 10, na? Yeah, 10 here. 240 by 10 will be 24 minus 2, 26 you are getting. M2 is 20 into 26. So you will get 520 Newton. Very good. Now you can go on with the bigger wedge. Probably I'll add one page here to it to complete this problem part. So let's look at that, the bigger block. So you have tension T here and tension T here. Normal reaction is there. And then we applied force. So because of all of them, it is going with an acceleration A0. Let's focus only on horizontal forces. What you have? F minus T minus N equal to capital M into A0. Minus T minus N. Okay. So F equal to T plus N plus capital M into A0. That is what you have finally. We got T already. We have got T there. How much is T there? Check it. T is 240 Newton. N1 is how much? 520 Newton. All right. So this is 240. This is 520 plus capital M is how much? Capital M is how much? 100 kg. A0 is 26. So you will have 26 into 100, 2600. And that is going to be the force. You have it. Sum it up, you will get it. So that's the idea we have. I think we have done about 14-15 questions. That is enough for the day. So again, tomorrow I'll come back with some more questions. So I hope you are following it. If you have any suggestions, please help me out and I'll be able to get back to you with the better ideas also. But for the timing, what my target is, take some important, very important models from PYQ so that you'll be able to cover most of the PYQ ideas there. All right. So with that, I'll conclude here. Thank you very much for joining. Until next time, goodbye.